Okay, we're dealing with section 9.2 on graphing the inverse variation equations. And here's an example. Graph y equals 6 over x. Now, I'm going to have a real big chart here, which normally you won't have to do. But I wanted to do it with you just once so you could see what's going on. We start by plugging in 6. That obviously will give me a 1. 3 will give me a 2. 2 will give me 3. 1 gives me a 6. But I even wanted some fractional values like 1/2. How many times does 1/2 go into 6? Well, 6 divided by 1/2, that's 12, isn't it? All right, how many times does 50 cents go into $6? Likewise, 6 divided by 1/3. Well, 6 divided by 1/3 is the same thing as 6 times 3, so that's 18. In fact, I'm going to have a big long list because I even want some negative numbers in there. So that'd give me -1 and -2 and -3 and then -1 being plugged in would obviously give me -6. -1/2 would give me -12 and -18. Okay, so normally we don't have to do this big long list of a chart, but I just wanted to kind of give you an idea of what's going on so that you understand the picture, and then when we move forward from this, we'll be sketching things. We won't be plotting exact points. So don't get hung up and think you have to do a big chart like this every time. So for instance, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I'm going to have to go by 2s on this one. 2, 4, 6, 8, 10, 12, 14, 16, 18. 2, -4, 2, -8, -12, -6. Okay, so there's just a basic looking picture, and then I can plot my points on here. 6, 1, 3, 2, 3, 2. 2 gives me a 3. 1 gives me a 6. And then we start as we get closer to the x-axis. 1/2 gives me 12. And then 1/3 gives me 18. What we're doing is we are getting a bunch of points that have a shape that looks like this. This is a branch of what we're dealing with. And then we'll graph the other one too with the negative numbers. Right, -6 gives me -1, and -3 gives me -2. Oops, that's probably closer to the axis there. And then -2 gives me -3, -1 gives me -6, and so on, getting me closer and closer and closer to these. This is also another branch. So this has 2 branches, and the overall graph has the name hyperbola. Okay, so every hyperbola in the universe has 2 branches. Now, what's the domain? The domain are all the possible x values. Well, if you look at this picture, there is only one possible x value that you cannot include in this, and that is 0, right? Because 6 cannot be divided by 0. And you can clearly see that there's a missing number in here in the middle. It looks like these 2 branches, as you come closer and closer to the x-axis, one goes real high, one goes real low, and they miss each other, and there's no point in the middle. These branches never connect. Never connect at all. Okay, so branches don't connect. In fact, they get really close to the x-axis, right here, and they get really close to the y-axis. And whenever you have a graph which gets closer and closer and closer and closer and closer to a line, but never touches that line, it's called an asymptote. I know that's kind of a funny word, but that's what it is. It's called an asymptote. So x equals 0, right? That's the official name of the y-axis. And y equals 0, which is the official name of the x-axis. Those are the asymptotes. Those are the lines that the branches get closer and closer to but never touch. So go back and look at the picture and you can see that again. Y equals 0 and x equals 0 are the two lines that it gets close to but never touches. Now, range. We didn't talk about range. Range are the possible y values, okay? I noticed that every y value that's negative and every y value that's positive gets covered, except there's one missing in the middle. That's where that asymptote sits at. So y can be any number in the universe except 0. Okay, we're gonna sketch several of these. Now, I want to remind you about the quadrants, okay? 1, 2, 3, 4. I'll even spell the word quadrants for you. C-W-A-D-R-A-N-T-S. Quadrants. So maybe that'll help you remember. 1, 2, 3, 4 going in counterclockwise fashion. Yes, I know that's not how you spell the word quadrants, but hopefully it will help you remember. Now, what happens if k is a negative number? If k is a negative number, what does that do to my graph? Well, when you multiply all the values by -1, it causes all the values that were on this branch to drop down in here. And it causes all the values that were down here in this branch to come above the x-axis. So it switches the quadrants. Now you're in quadrants 2 and 4. Whereas before, the hyperbola with a positive k value was in quadrants 1 and 3. What's the domain? Same domain, right? Every value except 0 because there's a missing value of 0 in the middle there. Y value, anything but 0, right? The asymptote. X equals 0, y equals 0 are the two asymptotes. Alright, so what happens if we put that y equals 1 over x plus 3? We put that plus 3 in the denominator. We'll talk about that in a second. Let's see here. Hopefully you remember it's being shifted, right? But it's being shifted 3 units to the left. So imagine that that vertical asymptote, which I'm going to use a dashed line for, moves over to the left. Now, so x equals -3, that's one of your new asymptotes. But since you only moved it left and right, the old asymptote of y equals 0 is still there. Now, since it's got a positive k value, I know we're talking about quadrants 1 and 3, quadrants 1 and 3. But that is in relationship to the asymptote. So you'll notice that they are, it's 1 and 3, but it's with respect to the new asymptotes. I know it crosses the y-axis here, but that's no longer an asymptote to this graph. So when you pick everything up and move it 3 units to the left, you move not only the points on the hyperbola, but also the asymptotes. So now my domain is any number in the universe except -3, and my range did not change because you didn't move it up and down, so every number except 0 works. So we will be doing horizontal shifts and vertical shifts. This one has both a horizontal and a vertical shift. Okay? And we're going to go with -1 just for fun on this one too. All right, let's see here. It's moving to the right 2 units. It's moving up 3 units, right, because the one on the outside is the shift. So my new asymptotes are x equals 2 and y equals 3. Because it is a negative k value, we're talking about quadrants 2 and 4. So respecting to the new set of asymptotes, quadrants 2 and 4. My domain, everything except 2. My range, everything except 3. Notice how these things kind of go together? Yep, that's because they do. Okay, so now, sorry, move my screen here for you. We want to write an equation for a translation of y equals 2 over x if the new asymptotes are x equals -2 and y equals 5. So think about this. Let's look at a graph and kind of sketch this out. So x equals -2, that's a vertical line over here, and y equals 5, okay, that's a horizontal line through here. X equals -2, y equals 5. So what has happened? We're taking this, it's got a +2 over x, so that must mean we're in quadrants 1 and 3, because it's a positive k value. So it's moved to the left 2 and up 5. So I need to rewrite this equation so that it says move to the left 2 and up 5. So there's my new equation. By looking at the picture, I knew that I needed to move to the left 2 and I knew that I needed to move up 5. And then I just needed to write the equation to make that happen. So that's one type of problem that you'll have to do. Another type of model is what happens if the denominator gets squared? Well, I'll give you a sketch of it. We won't go through it real long. It looks real similar in quadrant 1, but when you square all the negative values, instead of being down here, they're now up here. So you get a shape that looks like this. In other words, 2 branches, but they're not in opposite quadrants from each other. They're in adjacent quadrants. So like we're in 1 and 2. I also know I'm in 1 and 2 because the k value is positive. All right. This is not called a hyperbola. It has no cute name, so they call it an inverse square graph. So it looks like we ran out of cute names. The domain for this? The domain for this is all real numbers except what? 0, right? Because right in the middle there's a missing value. You can't divide by 0. What about the range? Well, it looks like it's all these positive numbers, but then it gets closer and closer to the y or the x-axis, but it never comes to 0. So this is y is greater than 0. And the asymptotes are still x equals 0 and y equals 0. Now, what if the k value is negative? Well, that's changing all of those positive values that were up here in quadrants 1 and 2, and it's bringing them down to quadrants 3 and 4. So you'll get the same looking picture down here in quadrants 3 and 4. Domain, everything except 0. Range, all y values smaller than 0. And my asymptotes are still the same. Nothing has changed about those. Okay, so what happens when you see something like this? This is showing me a positive k value. This is showing me left 2 units. So my vertical asymptote has been moved over to the left. My horizontal one has not been moved at all because nothing's being added out here. So we still have a positive k value. That means I'm going to have the new quadrant 1 and 2 branches of the inverse square. Domain, everything except -2. Y value greater than 0. Notice that I'm not putting equal to 0 because it's an asymptote, and by definition, the asymptote is never touched. So, x equals 0? Oh, no, that's not true. X equals -2. Now, y equals 0, that has not been changed, right? That's still the asymptote for the horizontal direction. Next, we need to sketch this one. I notice that it's an inverse square graph. It's got a -k value, and it's been moved. How has it been moved? It's been moved right 1 unit and up 3 units. So those are my new asymptotes. That would be x equals 1 and y equals 3. Since it's got a -k value, no, we're talking about the new quadrants down here, 3 and 4. My domain, everything except 1. And my range, all values less than 3. Not equal to 3 because that's the asymptote. And that's the notes on section 9-